speaker tonight is Steven J. Sasson, and he is the inventor of the self-contained portable digital camera. He was born in Brooklyn, New York, and received an MS degree in electrical engineering from Rensselaer Polytechnic Institute. He joined Kodak shortly after his graduation and ultimately retired from Kodak in 2009. Same year I did. In recognition of his role in sparking the mass digitization of photography, Sasson was awarded the National Medal of Technology and Innovation in 2009 and the Royal Photographic Society Progress Medal in 2012. Steve has graciously deferred a speaker's fee, and at his suggestion, we are making a donation to the technology collection at the George Eastman Museum in Rochester, New York. And Steve, I've talked with Todd, so we'll go ahead with that. Steve this afternoon sent me his CD, his curriculum vitae, and so for the first hour of tonight's meeting, I was going to read it. It's that long. But instead, he said, let's go short and sweet. So that's what I did. We're honored to welcome Steve Sasson to the Camera Club of Brevard. Thank you for joining us, Steve. Everyone give him a welcome.
Oh, thank you. I'm going to try to share my screen now. It says host disabled participation sharing.
Hang on one second. Let me get you. My fault, Steve. I need to get you in a co-host.
Okay.
Okay, you should be able to do that now.
Let's see, share screen. Oh yeah, there I am. Okay, and I've got Keynote. Let's see if that works.
There you go.
And then we do this. How are we doing? Does that look okay?
Looks great.
Okay, everybody can hear me all right?
I can hear you great.
Okay, well, thank you very much for inviting me to to speak with you this evening. It's kind of a pleasure for me to talk a little bit about some of the earliest days of digital photography, because when we were working on a lot of this material in the 70s, 80s, and 90s, we really weren't allowed to talk about it. So all these years later, to be able to tell the story is kind of fun. I'm going to start off by telling you the story about the first digital camera. This was a project that resulted in a portable, self-contained camera that electronically stored images digitally, and then we played them back on a television set. And as a part of this project, which was started in 1974 and ended in 1977, there was a number of presentations where this was demonstrated throughout Eastman Kodak, the company. And there was also, at the end of this project, I was required to write a report. And so the report was issued. It was about 60 pages. It was largely a technical report. But there was a part here, given all of the discussion that I'll describe to you later on, where I talked about where this might go and what my feelings were at the time. So, and this is the paragraph, I called it the camera of the future. And I'm happy to show this because this report was probably spread to about 80 different managers throughout Kodak, and then nobody ever saw it again. So if a number of people in the room tonight read this, we'll double the number that has done so in the last 40 years or so. But I was not allowed to talk about any of the work that I'm about to describe to you. Even though the cameras were operational in 1976, I was not allowed to publicly disclose any of this work until the year 2001. And that only took place because at that time, Kodak had changed its position and now really wanted to let people know they were actively involved in digital photography and in fact, indeed invented it. And so this was a picture of me holding that prototype camera. It was the first image, the first time there was any public description of the camera, and the first time it was ever seen by the public, and the first photograph ever taken of it by a public press photographer. So, but let me tell you how this started. It all started with a short conversation with my supervisor in my applied research laboratory in the Kodak Apparatus Division in Eastman Kodak in Rochester, New York. We were a small electronics group, and we really did a lot of stuff to support the design and manufacture of all kinds of equipment that basically utilized the sensitized goods that were produced by Kodak Park. And one day, Gareth came in to me and said, I had just finished a project designing a lens cleaning machine, and he asked me to if I'd be interested in, I got 2 projects that are filler projects, that is to keep me busy until something more important came along. And one was to do a modeling on exposure controls for XL movie cameras. But the other one was to get this new type of device called a charge coupled imager and get one and play with it and see if there's anything useful we could do with it. Conversation took about probably no more than 45 seconds. I said, sure, because in college, I had done my master's thesis on how light affected silicon, so I was kind of predisposed to be interested in this. And this device was first manufactured by Fairchild in 1975, and it was based on the charge coupling principle, which was first discovered by Boyle and Smith in Bell Labs in 1969. And applied to an imaging device. And this was the first area array that was fabricated. And it was made up of 10,000 pixels. There were 100 lines of pixels, and each line had 100, or each row had 100 pixels in them. It had a certain interline transfer architecture that allowed it to be suitable for interlaced broadcast, because all of the manufacturers at the time were thinking of trying to replace Vidicon tubes with this new technology. But this was very, very, very difficult to work with. It was a very experimental device. I like to tell the story about when I unwrapped the device and it came, on top of the device was a folded piece of paper with 12 pre-printed voltage designations. And next to each one, written in pencil, was how the voltage at which this particular device worked at when it left Fairchild. And at the bottom, it said, good luck. Because if any one of those voltages were a little bit out of line, you simply got no output. So it was a highly experimental device and was not easy to work with. I bought 2 of these because I was sure I was going to blow one of them up. Now, the situation was pretty clear. This was a filler project. When I say small project, it basically was not a project at all in the traditional sense. There was no project reporting. There was no budget. There was nobody checking on me. It was just this side little thing that I was supposed to play with. And so I had some part-time help. There were 2 really talented technicians, Bob Dieger, who helped configure the original architecture of the encasement that I used, and then Jim Schickler, who worked with me shoulder to shoulder as we went through the next year plus, designing, building, and debugging this experimental device. I had no budget. I was not allowed to buy anything for this. I couldn't justify anything for this. I could buy the 2 imagers, but that was it. So there was no budget, and there was no place to work either. I couldn't command a lab for this because it really wasn't a project. So I cleaned out there was a back lab that was used as sort of a closet, and we cleaned that out, and that's where we built this camera. So it was quite a low visibility activity. Now, the approach that I decided to take was, after looking around and seeing what I might try to, how I would get this to work, I realized that there was nothing really published on any of this stuff. So what I decided to do was take the output of this device, if I could get it to work, and digitize it rather than run it through as traditional analog circuitry, which is typically what would be done. And the reason I did that was it allowed me to freeze time. See, my object when I first started was to evaluate how this worked. And the best way to evaluate it is to put numbers to it. And the best way to put numbers to each pixel was to sort of freeze the pixel and digitize it, get a number to it. So I was thinking about, so I went all digital with this. And I thought after a while, since I was going to capture a digitized version of a charge pattern that was induced by a light pattern, that indeed I was capturing a sort of an image. And so I said, well, why couldn't I build kind of a camera type of a device and store it on some sort of removable digital storage? So there's where the idea, like a traditional camera, is you remove the film where the image was stored. It was going to try to do the same thing with this, except the image was stored digitally. And then I thought, even though nobody asked for this at all, I thought, well, it would be really fun, obviously, to measure the performance, but wouldn't it be great just to see this image? And so there was no way to print these images. So I thought, well, since I had it in an electronic form, why couldn't I generate an electronic signal and use the only display device I could get, which was a conventional television set? So that was the idea. So it required the construction of a playback device, and over half the effort, even though the camera is discussed and there's lots of pictures of it, half of the effort was in this playback device, because nothing like this had been built before, either the camera or the playback device. And in order for this all to work, both of them had to work in synchronism. Now, the great advantage I had here was I was inside of Eastman Kodak's research laboratories in the apparatus division and in the apparatus division itself. And so there was a lot of resources around there that I could leverage. And there were a lot of parts I could beg, borrow, and steal. Last emphasis on steal mainly. This is how, when I was a kid, I used to go around and pick up old television sets and take them apart and use the parts for projects. I kind of did exactly the same thing here. I went around and found parts that things that people didn't want anymore, or didn't know they had, or maybe it was in just basic lab stock. And that's how I ended up getting the parts I needed for this. After about a little over a year's worth of work, this is what was produced. It's kind of an odd looking thing. And this was the prototype camera. It was functional in December of 1975. And you can see how it was all put together like an erector set. And I'll show you some other pictures of it as well. The lens was, I stole that from an XL55 movie camera, and I put the imager in the imaging plane where the Super 8 movie film would go. So this was all jury rigged with respect to parts I could steal. The camera itself was about the size of a toaster, weighed about 8.5 pounds, ran off a bunch of batteries. The digital cassette was the final memory where we stored the information. And I set the pictures at 30. That was arbitrary, by the way. That was after I started showing this and getting pushback and lots of questions. What you try to do is make it look as common as possible. And since the two conventional film lengths at the time were 24 and 36, I just picked the arbitrary number of 30 and said that's what I set the bit rate at. So that was really not a technical decision, but a political one. The movie camera I mentioned too, and it was foldable. And let me show you, here's a picture that you might not have seen. This was also in the technical report. This camera would unfold totally, and I could pull those boards out of the bottom and extend them out to the right side so that I could work on it, because every single circuit that was built in this device. There was no building it somewhere else, trying it out, and then doing a finished version of it. Everything, first time and only time, was built in here. You can see the wire wrap on top. The top section contained all of the analog electronics I needed to get the signal to an appropriate level. And then on the bottom, you can see these little potentiometers, and that's where the adjustments were for the CCD itself. So everything was adjustable. This was the memory card that we stored. This device worked the following way. I had an exposure time of 50 milliseconds with available light. I would digitize it in 50 milliseconds, the entire image, and I would store it in that same 50 milliseconds in onboard DRAM. And then from that DRAM, after it was stored, I would read it out from the DRAM to a more permanent form of storage, which was the cassette tape that you saw on the previous image. So it was a two-step process. That's the first digital memory card probably ever, that one there. And I just throw this in to show you what the power supply board looked like. It was all hand-built and constantly being changed. And you can see that it was not necessarily a neat kind of a thing. Now, let me touch on the playback system because here's where I had to actually go buy something. I had to take a digitized version of 10,000 4-bit words. I digitized each pixel to 4 bits. And I had to reassemble them so that it would be appropriate to display on a television set. And in order to do that, I needed something that would electronically manipulate the digital image. I needed some sort of a computer, but this was before personal computers. But there were microprocessor development systems used by engineers to work with microprocessor chips for their custom designs. And so I wrote a little request to the lab we would do some research into microprocessor research, never mentioning this project, of course. And they thought it would be a good idea. And I was kind of a digital guy. So they said, okay. So they allowed me to several $1,000s to go buy a microprocessor development system. It was based on the Motorola 6800 at the time. And that's how I got that in there. But they didn't always kind of do it for this. So creative writing does come in handy. I had to build a video frame store board, and this board was something we never had built before. It was something that would take this digital XY version of the image and hold it after it was been manipulated and then read it out as if it were a typical television signal. So there was a lot of custom circuitry and software for image storage and video playback that we had not really done before. And we were using a lot of different technologies to try to get this to work. And then, of course, there was image manipulation via microprocessor, which, of course, seems so routine today. But back then, we had never done this, and not many people had. All of the manipulation we had to do with this was done with assembly language programs and UV erasable proms. So every time you did a program to try it, you would put it in this prom and run it. And then if it didn't run, you had to take it out and erase it with a UV light and then put in the new program. So that's kind of a thing. So, and then we output it to a standard television set. That was the idea. I wanted to have just a standard television set so that we could view this. Here's a picture of the development system. It was based on an architecture called NuBus, which was a publicly defined a backbone so I could build boards that would interface with it. You can see my tapes on the side there. And then you can see the image of the boy dog, which was our test image on the TV screen. So it's being displayed from this microprocessor playback system. Now, how do you evaluate an image? When I had this working, I went to our image people, which were all over the place. And I asked them, how would you evaluate an experimental black and white imaging system? And they said, well, of course, you use the boy dog image. That's the standard image we use for all kinds of black and white imaging systems for film. So I got a typical transparency, put it on a light board, turned it vertically, and then I had to hire a Kodak photographer to come up with a conventional film camera to take this picture. While it was the camera took a picture of this, we recorded it, put it into the playback system, and then played it back and then moved the TV set next to it. So there's the before, and there's the after. And this is the only image I have of how this camera performed. And you can see, and I'll try to make this even clearer, this had every artifact that was available to digital imaging at the time. If you look in the upper right-hand corner, you can see the contouring. That is, with only 4 bits per pixel, I couldn't get a good smooth gradient. You can see the stair-stepping on the dog's nose. That's due to the fact that I didn't have a good interpolation algorithm to go make those 100 lines into the 400 or so lines I needed to display on the television set to get the right aspect ratio. There are whiskers on that dog, which you can't see, and that has to do with the fact that there wasn't enough resolution. And then, of course, the dots all over there, the white dots, were photo response non-uniformities or even lockouts. This was the best version they could build of the device at the time, but it still was far from perfect. Now, the timetable here, the first picture we took, and this was the very first time that everything worked. One of the oddities that I'd like to get across is we worked on this for over a year, but we could never see an image until everything was done. Everything had to work in order for us to see anything. So all progress was measured up to this point by oscilloscope traces, voltage measurements, counters, that kind of thing. When it was done finally, I took a picture of a young lab technician. That's a picture of her right there, not taken with my camera, but taken with a film camera. But I wanted to show you who she was. She's probably the first person ever to have a snapshot taken of her with a digital camera. I went to her. She was sitting at a teletype nearby, and I asked her if she would pose for a head and shoulders shot, and she knew what we were doing back there, so she agreed to that. And I took that shot, and then when the tape started rolling, I walked back to the lab, popped the tape out, put it in the playback unit, and up the screen about 30 seconds later, after the manipulation was done, you could see her jet black hair. That was a real benefit because this image turned out to be really bad. Her jet black hair was quite visible and right organized geometrically on the screen, but her face was completely distorted and you couldn't recognize anything. And we were so happy about that because, well, we knew there were 1,000 reasons why we might not see anything. So to see actually the image with the right geometry was great, right? But of course, Joy had followed us back into the lab, was standing by the door. And we turned around and saw her, and she looked at us and she said, "It needs work," and walked out. And what I had done is when I had designed the playback unit, I had reversed the order of the pixels I was assembling them with. And so if you were all black, which was all zeros, or all the highest white, which was all ones, it didn't make any difference what the order was. And that's how we could see the geometry was correct. But everything in between, of course, was mixed up. It took us about an hour to figure that out. And I think we rewired it to make it happen. We wrote the technical report I described to you before. It was published in January of 1977. It was about 60 pages of technical description of how it worked. And the abstract was written right there. There was no bravado, no saying this was going to be great or anything. It was just simply what it was. Now, I demonstrated this to a number of groups throughout the company. And one of the groups was a bunch of patent lawyers that came. And after I demonstrated this camera to these patent lawyers, I got this letter. And I kept this letter not because I thought it had any historic significance at all. I had never gotten a letter from a lawyer before. And I thought, well, this is really cool. And I remember these guys, when they came, they all had suits on and they had watches. I was just, these were a cool bunch of guys. So I kept it. And you can read there that they were asking for an invention disclosure because Kodak may have an interest in patenting some aspect of this. So this is probably the first legal documentation for any digital photography right here. It was about 3 years later that the first patent for a digital camera was issued. And you can see here that the diagram was basically the block diagram of the camera as it was done. Things to note here, if you're familiar with patents, you usually see references cited, and you can see usually several pages. There was so little work in this area being done. There was only 5 sightings at all in the whole patent review. Let me head now to the next aspect of this, which are our demonstrations. Here's a picture. This is not the conference room. I found a conference room picture on the internet that had exactly the same dimensions, arrangement, door placement. Everything was exactly how it was for our demonstration. I was asked by management they gave me a list of people, and I didn't know any of them, and I would send out this invitation inviting them to a demonstration of what I called filmless photography, which is actually a pretty poor choice of titles given the audience I was about to present to. But they would come in and sit along a table like this, and I would come in, I'd fold my camera up because it was usually in the unfolded position because we were working on it. I would fold it up and I'd carry it in that door, and the person who was sitting at the front there, just on the left side, whoever it was, I took their head and shoulder shot of them. And then while the camera was recording it to the tape, I would explain what this thing was to cleverly hide the 23 seconds I was going to need before I could take a second shot. And then I would walk over to the person on the right side of that table there, and I would take a head and shoulder shot of that person. And then when the tape was done, recording, it would stop. with the second image. I would pop the tape out and I would hand it to Jim Schickler, who was in the back. So the lower right-hand corner of the image, we had put a card on where we put that little playback unit. And we put the cameras up and put the tape in the machine. And after about, I think it was exactly 30 seconds, that image would pop up. And that was my demonstration. And I will tell you that in the dozens of presentations I made throughout 1976, I never got much further than that first image, because that's when the questions started. The reaction, management didn't know what I was doing. Even my reviews were just periodic reviews with Gareth Lloyd, my supervisor, and I would review what projects I was working on, and then I would just casually mention progress on the CCD project. In fact, when it was first operational, just to show you how little there was, when it was first operational, I went into Gareth's office and I said, "Hey, the thing works. We took pictures. It works. Want to come and see it?" And he said, "Yeah, we'll bring the head of the lab in." I said, "No, it's portable." "It's portable," he said. He didn't know I was building a portable camera. I had never mentioned it to him. So that's really what was, it sort of took people by surprise. So it was a conference room demonstration of a complete electronic photographic system. And what I mean by that was I was taking pictures with available light with a portable camera, and I was displaying those pictures less than a minute later on a television set. I wasn't using any film. I wasn't using any paper. Okay, it was completely without consumables. And it was a whole system. Now, the overall reaction was it was too far out there for serious consideration. The way I would describe it is they were very taken aback by the fact that it didn't use any of the things that the industry and certainly our company had depended upon as a business model for the last 80 or so years. I was not being shy about it. I was saying this was could replace eventually, consumer photography or consumer photographic film and paper. And that was so far out there that they just didn't want to seriously consider that possibility. Example, what would happen to our well-established photo finishing chain of consumer touch points, photographic stores, drugstores? They sell film, they sell paper, they do the developing. What happens to them? And because I was kind of an idiot and I didn't really think about any of these questions, I said, well, they can sell batteries, because that was the only thing I was concerned with. So that didn't get very far. They were sure that people wouldn't want to view their images on a television set. And it was kind of strange because we had a slide business where people would sit and look at slides. But TV, of course, obviously had much lower resolution and all kinds of artifact issues. So they were kind of convinced that nobody would want to sit and look at this on a screen ever. And then a lot of questions: how to store images. What would a electronic photo album even look like? Okay. And how can you get to film-like quality, not to mention color, because these were only black and white images. So there were lots of technical projection questions as well, none of which I could really answer. I had thought that when I demonstrated this, especially to technical audiences, and there were lots of them, that they would ask me, how did I get all this to work? All this different technology, we pulled it together for the first time. It never worked like this before. And nobody cared at all about it. They didn't ask me how it worked. They asked me why. Why would someone want to do this? Why would this be useful? What advantage, what problem are you solving? And I hadn't really thought too much about it. I simply thought that if you only had to expend a few joules of energy to capture an image rather than wasting a lot of chemicals and paper and film and all that, that would be a plus. So that's kind of how a lot of the discussion went. Now, I want to take it just for a second back to the context of 1976. These demonstrations were taking place inside the company. And I want you to put you in the frame of reference that the audience was in. First of all, I was proposing this as a replacement for consumer photography, and it was a completely digital project. It was all digital technology. There was almost no analog in this. And digital was not part of the consumer experience at all. In fact, it had a kind of a bad reputation. It had a reputation of being complicated, esoteric, expensive, unreliable. And so, in addition to what I was doing, how I was doing it was also suspect in terms of being practical for any consumer application. So what you have to do in those cases was use analogies. And so I found myself using analogies and describing what I thought this could eventually become. And the only digital product that I could think of that was available were calculators that were coming out for engineers, largely engineers buying them. The HP 35, if there's some gray hairs in the audience, you might remember this device. This had just sort of come out. It was about $400. And I said, well, here's something that consumers buy, if you consider engineers consumers. And I said, so think of it as a calculator with a lens. I was trying to get this idea of a consumer device based on digital technology, but also capturing images. Now, we brunched a number of topics in those meetings, probably for the first time in regards to digital imaging, because people had imaginations. I don't want to give the impression that people were totally against this. There were people trying to think outside the box if this could be the case. Personal computers, for example, were not available yet. At the same time Jobs and Wozniak were launching their new Apple board. And I had become familiar with this because Wozniak used the same DRAM chips that I had used. And I thought, well, boy, maybe I could somehow press this device that they were putting together into some sort of playback device. I didn't do any analysis on it. I just saw that somebody was providing something with a lot of DRAM and a microprocessor on a board that somebody could afford. And so I thought, well, I use this as a kind of a little glimmer of what might happen. Now, the problem with analogies is sometimes people track you down on them. And I never forget a guy from consumer imaging. He stood up, I never forget this because I had no answer. And he said, okay, Sasson, how much for that calculator up there? I said, about $400. How much for the board from the guys from California? $700. Okay, so for $1,100, you can take way worse pictures than a fully loaded Instamatic for $35. Why are we talking about this? I didn't have an answer other than it'll get better. And so that was kind of one of the initial reaction to it, as to how this could ever become practical. We did talk about sending images over telephone line, largely point to point, as you might do with modems. And we did talk about that as being one of the advantages of some approach like this. The internet, I think, was brought up, called ARPANET at the time. It was brought up, and this is about how it was in the mid-1970s. It was largely between universities that were doing sort of DoD kind of research. But it hadn't really taken the character of what we know of it as today. But we did touch on that ever so briefly. Local area networks, we didn't talk about those because we knew we needed something like that, but we had no idea how that would actually go forward. How would you get these images around? The idea of it being a tape and handing tape around never appealed to anybody. And they knew electronic transmission. They just didn't know how to make it easy. And then photographic printing in the home. The idea of printing actually something out. The idea of electronic viewing, as I mentioned before, was really not very well accepted by most of the audiences. But they said if you could make a print with it in your home, that would be very interesting. And so this was way before inkjet or thermal dye sublimation was coming along. But there was research in dye sublimation going on at Kodak, I think, even at that time. So let me touch on what happened next. Color. There's a fellow named Bryce Beyer. Beyer and he is a mathematician largely in the Kodak research laboratories. And I met him once. A mutual friend, Ken Peralski, introduced us, and we sat in his office for a while. We just chatted a bit, and I had read about his work on trying to get color out of a monochrome image, and I had no idea how to handle color. And so he had around this time gotten a patent on what's called the Bayer array, and of course, probably everyone in the audience knows the Bayer array that's what you've got on your cameras. And that's how it is. There's the patent number. I urge you to read it. It's not really about imagers or digital cameras. It's about how the human eye sees color and at what angles. It's what the strength of Kodak was. We knew the problem that had to be addressed. We didn't know the technology that needed to address it, but we knew what problem and how they had to be solved. So that was work going on at the same time. I even mentioned that in my technical report. In the mid-'80s, Morita from Sony made an announcement that he was going to take over the photographic business with his 2-inch floppy disk. And I was really happy to see this because I did the analysis on this for the company. And it was, it's so funny how companies do the thing that they know the best. And so they did sort of a modified version of VCR kind of recording. It was an FM, what's called an FM color under system, much like an NTSC signal, but with the subcarrier moved way down. And so it was really stuck with TV resolution. And what this was a small camera that would record one field or two fields, making a complete frame on this disc as it rotated at 60 hertz. And then you would play it back at 60 hertz. It wasn't digitally stored. It was analog. It was an analog television signal stored. When I analyzed it, I realized this was really great for two reasons. One is it would never work. It would never replace photography because there were inherent limitations in the signal processing that they were depending upon for this to work. And you can't replace a photographic system with one that's worse in its primary attribute, which is image quality. And there was no way to get better. But they thought they could fool people into watching it on TV set and they think it would be okay, right? But the other reason I liked it was because Sony, which was a formidable new competitor, was saying they were going to get into the electronic imaging business. And you might know that if you're in an established enterprise and you're proposing some sort of disruptive innovation, you're kind of the last person they're listening to. However, when a major competitor starts talking about it, they start listening. And Kodak did. Kodak's management did. And they started listening from the very early 1980s. And they were working secretly on megapixel imagers. Most of the RCAs and the Fairchilds of the world were trying to replace Vidicon tubes. And once they got to 512 kind of resolution that was adequate for NTSC or PAL or CCAM, they kind of lost interest. And we knew that in order for this to ever be good, it's not going to revolve around the television set. It's going to revolve around the computer and a very high resolution because film had very high resolution and prints had high resolution. And so even though they worked secretly on these devices and they were leading the world in making these devices, they never went public with any of this stuff. The only time they went public was at a I think it was a Mac World show where Sony was showing off one of their NTSC resolution sensors. And everybody was getting so interested in them and looking at them for imaging. Our management got nervous enough, said, okay, just show them a little taste of what we could do. And we demonstrated the 1.3 megapixel imager just for 2 days, I think, at the show, just to show, because we had this public perception that we didn't want people to think we were behind in this. We were not. We were working very hard on the answer. We just didn't like the answer. But we were working very hard on it. The last problem is something I want to share with you about image compression. As images get bigger and bigger, image sensors, and you had higher bit depth in order to get the true color depth that you needed, the memory requirements were getting astronomical. And even though memory was increasing in density and lowering in cost, it wasn't going fast enough to get there anytime soon. So there was a lot of work being done in image compression, and Kodak was one of the world leaders in this area. Again, not telling anybody about it. I want to tell you about a project or a product that was actually offered for sale in 1987 that, in my opinion, was one of the hallmarks of digital imaging that nobody knew about. It was the first time we ever went public with any of our work that involved image compression. It was a device called the transceiver. It was something that looked like a VCR, about the size of a VCR. And it was basically, you captured an image with this device. It would then compress it to fewest bits as possible, and then send it over a telephone line with a 9600 bit per second modem. And then an identical unit would receive it, reconstruct it, and then create a full resolution image of it and display it. So 2 units, identical, could do 2 different things, and you could use that as a pair to transmit images. Now, there was no market need for this whatsoever. I couldn't justify this, and I never tried to justify it. But we worked on this and convinced the management that we should do this and offer it along with a bunch of products that were dealing with the still video floppy standard in the 80s. Because I thought, well, this would fit in with the product, even though it had nothing to do with still video floppy. And we could take the image compression technology that we were working on in a research laboratory and actually put it into a product. Never been done before. Which algorithm do you use? Well, I went to Majid Rabbani, Dr. Majid Rabbani, who is one of the world experts in image compression. And I explained to him what we wanted to do, and he was very excited to work with us on it, because all he did was work with big giant computers and do detailed prints and look for artifacts and things. And so he said, I said, which compression algorithm? Because there was about 24 different algorithms being proposed around the world for the standard. And he said, use discrete cosine transform. When I went back and looked at what was required for that, I saw that it was computationally very intense. And I said, geez, Majid, I know you're a really smart guy, but this is like really hard. And he said, well, that's not my problem. That's your problem. You want to know what's the world going to decide on it? Whenever they get around to deciding, this will be it. And 1987, he told me that, and it was in 1993 that the JPEG standard, which was based on DCT, just what we did, was standardized. So he was right. And so this is the kind of help I had at Kodak, world-class work. And what we did with this, when you do a discrete cosine transform, you transform that 8 by 8 block, in this particular case was 16 by 16 block, from pixels at different points on an image, and you turn them into sort of a cosine related wavelet. And then that is more suitable for removing information that's not important to your eye. You can, by looking at the geometry of where you are in that matrix, you can remove spatial frequencies that you know you can't see, and then therefore remove bits. So we could get a compression of about 8 or 10 to 1 with this, and we were very successful in getting basically visually lossless compression and decompression across the unit. We're very happy with this. I didn't know who the heck bought this thing. I didn't really care, and hardly anybody did. Well, one person did, and it got unexpected attention. In 1989, there was the Tiananmen Square uprising, and CBS News had bought 2 of these, unknown to us, and they had one in China and one in New York. And when the Chinese shut off all the ways to communicate out of there due to trying to limit world exposure to what was going on, they didn't know about this device, didn't know it existed, and they started using it, and they were the only people to get images out. And they were so excited about this new technology that was actually radically changing the way they were reporting. They wanted to do a news story on it. Now, this was on their only 3 major news outlets in the United States. So having one of those say, I want to do a full news story on your brand new technology, wow, what a break, right? Well, no. Management said, no, you don't want to do that. You're going to offend all our photographers out there. That's going to be a real problem. We're going to have to explain why we're doing this. Well, we had a VP in charge of the product portfolio that this was part of. His name was Brad Paxton. And he said, listen, we'll do the story, but we won't mention Kodak. We'll tell him to call it something else. and we won't say anything about Kodak. We'll just demonstrate the technology. So they did that. And I'm going to show you this video now. And I want you to notice that we did manage to get Kodak on the screen because the splash screen showed Kodak. You'll see the images coming up very rapidly. That's by an incredible amount of technology we had to apply. I actually had to flew down to Texas Instruments and find the guy who made their graphics chips to custom encode the DCT kernel for us. Just a lot of remarkable technology pulling together, and you can see that coming ahead. So just take a look, and hopefully you can hear this as well.
On the streets of Beijing. Now, the sights we have seen so far have been gripping, and it has taken a marvel of technology to get them out of the country. We have that story from Channel 2's Jane Velez-Mitchell.
They've roughed up reporters, but the Chinese government still hasn't been able to stop it. The flow of compelling images, massacres, monumental courage, pictures that have galvanized world opinion. The horror stories have kept seeping out, even after Chinese officials confronted CBS News anchorman Dan Rather and made him shut down the satellite that was used to feed videotape of the historic democracy movement. After the Chinese officials shut down a satellite, they may have thought that they had stopped the flow of videotape from China to the rest of the world. Normally, that would have been true. Normally, you would have had to have physically transported the videotape to another feed point in Tokyo or Hong Kong and sent it from there. But in this case, thanks to new technology that CBS used for the very first time during this crisis, the network was still able to get dramatic pictures directly out from China to New York and then to the rest of the world. It's called a transceiver or pixelator. Folks here at CBS Network call it a magic box, a machine that takes moving pictures, captures a single frame, then breaks that frame down into computer information or digits, and through an ordinary phone line, sends it to a similar magic box in New York. It then takes the information and turns it back into a single picture. Reporters in Beijing then use a cellular phone to speak live on television from Tiananmen Square over the pictures.
You hear that gunfire?
What are we doing here?
Okay, we gotta get out of here.
Commandeering the crisis coverage for CBS, Lane Bernardos, director of special events for CBS News. He says that single piece of equipment, the magic box, has changed the face of its news coverage.
This is a godsend. We could not have done what we've done over the last, say, 36, 48, 72 hours without this kind of device.
To the Chinese, it's been a lifeline to the world.
We took in some still photographs of crowds cheering our TV crews. They're so happy to see us, even though it's forbidden now officially. The people are saying, they were saying to our crews, get our story out.
While the Chinese could confiscate the magic box in Beijing, fans of the new technology feel no regime can stop the flow of technological advance and predict the future will make it increasingly difficult to violate human rights in an ever-shrinking global village. Jane Velez-Mitchell, Channel 2 News.
Okay, that's goes in the category of you just never know. We were not looking for any kind of publicity at all. This is the first time any of this technology that we had been working on for the last 8 to 10 years actually went into a product that was for sale. And the corporate management didn't know about it. And when they did, they basically said, what the hell are you doing? There was a whole tension now between this new technology being introduced as a product and somehow affecting our existing product sales. But why did we do it? Well, the reason for doing this project was to see if we could do this compression really good, really fast, and really cheaply. And so what was this device? This device was a frame store, something that would capture an image, this DCT compression block, which is a computational gymnastic technique and eliminating the bits, and then a modem where we would send it over a telephone line, and we would hook a video camera to it to capture the image we wanted to send. But what if we could do this, and we wanted to replace that with one of those megapixel imagers that the Kodak Research Laboratories were working on. And then we replaced that modem with a memory card that was made by Hitachi. There were several of them coming out now. Shrink the whole thing down, put some batteries on it, put a lens on it. What do you have? That was our overall goal. but we couldn't go there directly. We had to take this one step. This was a project that we started in I would say 1987 or so. We worked on it for 2 years. This time I enlisted the help of a real camera designer. His name was Robert Hills, and he had designed every single film camera that Kodak had ever made for every film format. He just knew everything there was to know about cameras. And when I approached him with this idea of building a camera that didn't use film and would use this technology, he was curious, but he also knew that he didn't want to build any stupid looking things like I built. So he said, Sasson, I said, we'll build it, but it's not going to look like some dopey thing you would build. It's going to look like a real camera with real camera parts. And if it doesn't do that, we're not going to do it. So Bob and I agreed to take on this project. We had a great team of people put together. And I'm going to show you, it was operational in 1989. 6 of these were hand built. It was called electronic eCam, basically electronic camera. It was built with chin-on parts. It would capture images by a 1.3 megapixel sensor. That's the megapixel 1310 that was made by the research laboratories, was digitized very rapidly, did image compression very rapidly, and then stored to the memory cards. So we built these, relatively small team, took us about 2 years. Again, we could not talk about any of this stuff. We finally got them together, and the pictures were actually really looking pretty good. And we went to Professional Imaging, the marketing arm. And I never forget Bob. I didn't attend that meeting. Bob did, and he came back and he told me. He said, I asked him point blank, could they sell this? And he said, yeah. They answered, sure we could, but we won't. Why would we? How does this help us with any film or paper sales? How would I train these guys on this? Where's the recurring revenue stream? Why are you doing this, right? And so Bob came back and was very discouraged. And he decided to, he said, I can't stand you electronic guys. They don't want it. So I said, well, before you leave, let's write an invention disclosure on the architecture of this camera. And so we did that. And that resulted in a patent called the 107 patent. And this patent is one of the fundamental patents in digital photography, I think. It was years later when Kodak was involved in many, many patent litigations and licensing programs. This patent was one of the 4 fundamental patents that represented their position. And in evaluating that, I just put down here in the early 2000s when people were evaluating the strength of the positions that Kodak was taking, because Kodak traditionally didn't sue for intellectual property. In the film world, that didn't really happen very much. But in the digital imaging world, it was very cutthroat. So we were doing it. And you can see what some of the reviewers thought, that this patent was a really pretty strong patent. It turned out to be pretty strong. There were a number of litigations that took place over the next few years in the early 2000s, about 2006. And I was involved in all of these because I was asked to help project manage the litigation, which is a whole interesting discussion. It could be a whole subject of another talk. But you can see that this patent, along with 3 other patents, some were done by Ken Peralski, and I think Jim McGarvey had some, and that represented a portfolio that eventually every single camera manufacturer in the world licensed, and cell phone manufacturer. They all licensed it at one time or another. So Kodak, in the end, I think made a lot more money, or more money, off of licensing revenue than they ever did off of any digital camera sales. I can't prove that, but I was involved with some of the settlements, and those settlements were eye-watering in my opinion. But let's talk about what happened in the early 89 and 90. Jim McGarvey pulled together a team. Some of the eCam guys actually went over there because we couldn't proceed with the project because nobody wanted the camera. And he built what's called the Hawkeye imaging accessory. I think there was only a few of these built. It was built using the same imager we used in eCam, but they used a stock Nikon F body. It could take 2 pictures a second, had an ISO range of about 50 to 400. And one of these went across above in the space shuttle in 1991. It's the first time a digital camera flew in space. But it was kind of like 2 years later, something called the Professional DCS came out. It was sold for about 3 years. And you can see it was a camera attached to a tethered box. There was almost 1,000 of these sold to largely press photographers who valued the fact that they could take a picture and send it back to their studio or editor or whatever immediately. They could also view the image immediately. And they also had an optional JPEG compression board that would go in this. This was a part of a cultural challenge that we faced, and that is that real photographers were afraid of doing image compression on their images. Wasn't required for film. Why are you doing it here? You know, tell them that you're going to lose 80% of the bits they just captured, and not with my image, you're not. So even though you couldn't see the difference, at least in most applications and most images. But anyway, this was probably the first successful implementation. It was sold through 94. No, yeah. And then 1 year later, we came out with a called the DCS 200. This had a 1.5 megapixel imager in it, and over 3,000 of these were sold. And this was based on a stock, as you can see there, an 8008 body. It held 50 images on a 2.5-inch internal SCSI drive, and it was all in one. Okay. And also, I have to tell a funny story. Our Kodak designers were so angry. We were using Nikon cameras, and that was all of the signage on the camera was Nikon. Nothing said Kodak on it. And even though it had nothing to do with Nikon, we didn't work with. We just bought the cameras. Nikon didn't know what we were doing with them. So this time they insisted that Kodak appear on the camera in bigger letters than Nikon. So that's why you have that there. Apple came to us in 1994 or 93, I think it was, and they knew that we knew a lot about cameras, and they were the imaging computer, and so they wanted to get an accessory for their computer to get images and into the computer. So we secretly signed a non-disclosure with them and an agreement. We would design and build it. Our management, corporate management, agreed to this only if the camera, which was going to be consumer now, didn't look like a real consumer camera. It had to look like something different. So they had to design it to make it look like a binocular. So that's why the shape it is what it is. But the QuickTake 100, which was launched in 94, was 640 by 480. It was the first sub $1,000 color camera. Held 8 pictures and took 4 seconds to take a picture. But that was all marketed by Apple, all Apple name. Kodak didn't say anything about it, but we designed and built the whole thing. And then in the next year, the DC-40 came out in 95, and you can see, obviously, we leveraged all of the stuff we had done for the QuickTake and put it in there. And these images were slightly bigger, and it was slightly faster. And the camera, it starts to get really complicated after this. I just want to end the talk with a simple slide. And a realization here, if you take a look at, this is how rolls of film were being sold in the 95 to 2000, and then from 2000 to 2010. And you can see between 95 and 2000, film was increasing. At the same period of time, analog cameras were increasing in sales. And this was the very time we were trying to bring out digital photography. We were making great strides. I just described some of them to you that happened during this time period. The DC-210, which was a consumer camera, which is the first megapixel camera, and a lot of people think it was the first demonstration of what we call the dominant design. That is a camera that had a memory card and a display on the back, exposure control, downloaded electronically, all the things we take for granted today first showed up in that. That was in 1997. So you can see, while we were making great strides in perfecting the design and architecture and implementation of digital photography, we were fighting an uphill battle when it came to film sales inside of Kodak. And it was only until we started hitting, after that, the consumer camera started to take off as well as professional. And you can see then, of course, it fell off a cliff. And then that's when digital photography started to take over in cameras, and cell phones took over after that in the late 2000s. So anyway, I think I'm over my time a little bit, and I apologize for that, but I wanted to give you the whole story. Thank you very much for listening, and I'm happy to dialogue with you about any questions you may have.
Thank you, Steve. That was awesome, wasn't it, you guys? Every single person in this room, his invention affected what you do. And it's amazing to think about that. It's just historic, really. And it's just amazing. I hope you have some questions for Steve. You're really not over any time limit, Steve, so.
Oh, okay, I didn't know. I know we were shooting for 45 minutes, and I just looked up, and I'm close to an hour here, so.
Yeah, so I'm looking out at about 80 people here that are in the room. I took some photos for you, Steve. I'll send those to you tomorrow. Does anybody have a question? I know I have one that I bet you a lot of people are asking. Where is that first camera, foldable camera? Where is it? Is that in the technology collection?
Oh, the prototype actually still exists. Now, by all legal rights, it shouldn't. When you build any kind of a device using R&D funds, R&D, that is government-sponsored kind of things, you're supposed to destroy them. You can't get a tax deduction for money spent on something commercializing. You're going to commercialize. However, since nobody was really paying attention, when the project was over, it was just too cool a thing to get rid of. So I kept it, and I kept it for years and years in my desk drawer or in my file cabinet as I moved from job to job and location to location in the company, my career. In fact, I lost it one time, and somebody finally brought it into me and said, "Is this thing yours?" And I said, "Oh yeah, I had left it in a cabinet. I had moved the job." So on the back of it, I stuck, "Please return to Steve Sasson," a little sticker handwritten. So the camera still exists. It's been all over the world in demonstrations, and it was in the Smithsonian for several years. And then Kodak pulled it back and put it in their museum in Rochester, New York. So that's where it is right now.
All right, that's great. Any other questions here, you guys? Yeah, over here, wait a minute, Liv. What kind of digital camera do you have now, Steve?
Well, if you ask my wife, it's too many. And actually, I don't have that many. I have some Nikons. I did consulting after I retired from Kodak, and I did a lot of consulting on Nikon. So I accumulated some Nikons, but I don't have that. I have a D750, I have a D500, and I have one of the new mirrorless cameras, a Z50, which I really find is a cool little camera. I like it a lot. But those are the only ones I have. I tend not to collect cameras. It's a dangerous profession, you know.
All right, thank you. Curtis?
Is there anything Kodak could have done different over the decades that they could have come out in better shape?
Oh, could you repeat that? I didn't understand the question.
Would Kodak have done anything different during your time of employment, which would have made things better?
Kodak didn't come out with.
Oh, I see. So I guess he's talking about the marketing and the invention of the digital camera, where Kodak just kind of wasn't efficient with its timing. They got hurt by it. So, because other people kind of jumped ahead, right?
Well, yeah, it's a complicated story. One of the reasons that I so look forward to giving this talk tonight, because I'm talking to photographers, I get asked more often than not by business schools to talk about the whole problem of how to deal with the disruptive innovation inside of established enterprise that's displacing a very profitable product. I mean, I don't think I'm giving away any secrets by mentioning that film and paper were a very, very profitable consumer product. And so Kodak struggled mightily with it. I'm not kidding when I say that we knew what the right answer was. We didn't like it because we couldn't come up with a business model that could compete or be somewhat equivalent to the success of the business model of film and paper. You know, that the film and paper was, well, it was just an incredibly brilliant product offering. I mean, think about it. Every time you took a picture, you had to go to the photo store to buy film. Then you would put it in your camera. You would use it. Then you would take it out of your camera, bring it back to the photo store, ask them to develop it. And then a third time when you picked up your prints. So you had 3 visits, 3 customer contact points for a single event with one product. Pretty amazing. That's why photo stores really liked it, you know. We were replacing that. And that was a real problem, not to mention the profitability of film and paper, of course. So Kodak was hesitant to publicly talk about any of the work we were doing. And then when we offered these products in the 90s, they were, you know, offered by other people like Apple. You know, people saw Nikon on the camera, so they said, well, it must be Nikon, you know. And then when in the early 2000s, when it started to become very acceptable, then we said, well, we want to be a player in this field. And we did. And we got in there. We were at some points during the early 2000s, the #1 or #2 seller of consumer cameras in the United States, I think, right? However, there was no profitability in it. I hope I'm not giving away any secrets, but we lost money on those cameras. And so they eventually had to get out of that business. So they made the right decisions, I guess, from a consumer point of view. There's many books, if you're interested in the business aspect of this, and all of the proposals that were done by all of these famous authors that wrote books about how to do displacement. Apple Computer came, Steve Jobs and Bill Gates were at Kodak. They were all trying to figure out how we could work together. They were even thinking about buying Apple at one time. So there was a lot of business strategy around how to deal with this transition. None of it successfully implemented, simply because we were too successful in the existing business we were in.
All right, another question? Yeah, how sensitive was the original camera taken, I assume that? ISO value of the original digital camera?
I'm sorry, the echo is so bad I can't hear. I need somebody to speak right into the microphone.
Did the original ISO value for the original digital camera?
Oh, the original ISO value? I never calculated it. I may have it in my technical report, which I don't have here with me, so I don't know. It was a 50 millisecond interlaced exposure, so really each pixel it got 50 milliseconds worth of exposure, and I was exposing largely under now I would say fluorescent lights and incandescent lights. I was not allowed to bring the camera outside. For some of the dumbest reasons I don't even want to repeat here. They were so dumb. So I took all the pictures were taken inside with available light photography. And since the pictures were recognizable, I wasn't trying to, create any beauty pageants with this, beautiful pictures with it. I just wanted something that was doable so that when people get the concept of the idea of electronic capture, electronic display, no consumables, just using energy. And that did get across, okay? And that's really all I was after. So I never really tried to make the pictures even more beautiful, and therefore work on sensitivity at all. I didn't have any control over sensitivity with the imager. It either worked or didn't work. And also if you got too big of a dynamic range with it, they would bloom. In other words, the pixels, the electrons that would gather under the pixel sites would just, if there were too many of them, they would bloom over and they would spread vertically in the shift register and ruin the image. So it was a very narrow photo space I had to work in.
Thank you, Steve. Any other questions here now, or we'll turn this guy loose? Steve, thank you so much. It's an honor.
Okay, thank you very much. I really enjoyed it. Again, I like talking to photographers and talking a little bit about some of the things that go into, you know, what we're all using today. So it's kind of fun. So I appreciate it. Thank you very much for inviting me.
Okay. And we'll send you some images. I'll send you a couple images that we took tonight for you.
Oh, thank you. I appreciate
All
that.
right. Thank you very much, Steve. Steve,
Bye.
yeah.
Bye.